professional journey in Compact Center when I was heading the particular center. And then on, in fact, he joined my previous organization, in which he was a very pivotal member of the group, which essentially we grew up to more than 1,500 engineers. So Amit, it's a pleasure to see you in a very different avatar as such. So along with that, in fact, it's my pleasure to welcome Guruprasad Shanai. So in this particular, we will see more on what are all the particular aspects of the cloud security, how essentially it is managed, what are the risk management that is associated with that particular. So in this particular, Amit, once again, thank you, Amit and Guruprasad. Thank you very much for your time in advance. Sir, now I will hand it over the mic to our principal, Dr. Prakash, sir. Sir Prakash, you can invite them on behalf of the institution, sir.
Thank you, Prakash, sir. Thank you so much. Sir.
Thank you, sir. Thank you.
Sir, mic is on mute, sir.
Mic, no, sir, I'm not on mute.
Sir, no, it's audible, sir. It's audible, sir.
It's audible, sir?
Yes, sir, it is audible.
Fine, sir. Thank you, sir. I think at the outset, let me thank Amit ji and Guruprasad ji. Sir, thank you so much for taking time. Very kind of you, sir. It's an honor and privilege from our end to host you. Both are cloud architect experts. It's always nice to listen from the experts. I think since past few years, many enterprises have moved on to the cloud. Everyone has this challenge: how secured I am on the cloud. Definitely, it's like my bank, where I keep my gold on the bank, where it is, I have both the keys, one at the user end and one at the bank. But still, sometimes theft do happens at the bank. So this is the time where, since so much of applications and so much of enterprise applications are migrating onto the cloud, and it's always necessary how secured I am on the cloud. Thanks for this great topic what chosen by Satish sir. All my academicians, a lot of academicians I see who are working on cloud security as a research. I've been working on AWS. I see a lot of when I download Putiki, where it saves, how it saves, whether the security is at the application level or whether it is at the virtualization level, whether how I have allocated some VMs, how that it migrates somewhere to some other data center. When we read all this virtualization concept, we see that very easy to manage all these things at the virtualization level. Definitely I love to hear from the experts, sir. I don't want to take much time. Thank you so much once again, congratulating computer science department and specifically Satish sir for getting these great experts exclusively to our college. We are privileged and honored to have them here, sir. Thank you, Guruprasad ji and Amit ji. Thank you so much, sir.
Very kind of you, sir. I think it was a very wonderful introduction to today's webinar. Now I request Professor Shilpa Patil to introduce Amit ji and Guruprasad Shanai formally to all the other people. Over to you, Shilpa ji.
Yes, sir. Good afternoon, everyone. Am I audible, sir?
Yeah, good afternoon.
Yeah. Good afternoon, everyone. I'm Professor Shilpa Patil, faculty from CSE department. It's a pleasure for us today to hear from industry experts about cloud security. We have with us today Mr. Amit Agarwal and Mr. Guruprasad Shinoy from McAfee. Let me introduce Mr. Amit Agarwal. Mr. Amit Agarwal is a senior product manager at McAfee from December 2017 till present. He has 21 years of experience in product management and engineering. He leads the IA security product for AWS, Azure, and GCP. He is responsible for product strategy, investments, roadmap, marketing, field training, and close interactions with all stakeholders. He is passionate about product management and solving end user problems. His skills are entrepreneurial spirit and a team play. He's also a team player. He has a patent for vendor risk analysis to evaluate riskiness of vendor based on multiple parameters. He was also a product manager at Sky High Networks from 2013 to 2016. He was also a senior product manager at High Sky Networks from 2016 to 2017. He has also worked for Brocade, HCL, and Tidal Data Solutions. Now, coming to his educational background, he has completed his MBA from IIMB, MS from BITS Pilani, BTech from NIT Warangal. On behalf of East Point College of Engineering and Technology, I welcome you, sir.
Thank you, Ma'am Shilpa.
Yeah. Coming to our next speaker, Mr. Guruprasad Shenoy. Mr. Guruprasad Shenoy is currently the Senior Cloud Architect in McAfee. He has also worked for Sky High Networks, QLogics, and TCS. He has an overall experience of 15 plus in network security. He is also a passionate programmer, quintessential techie, opinionated cricket enthusiast. Coming to his educational background, he has completed his MS from BITS and B from BTU. On behalf of East Point College, I welcome you, sir.
Thank you, ma'am.
Over to the speaker, sir. Amit, sir, you will be presenting first.
Yeah, sure. I can just give an introduction and then we will switch between myself and Guru to go over the presentation.
Yes,
so
over to you.
Thank you. So I'd like to first thank Dr. Satish, Prakash sir, Shilpa ma'am, and Dhananjay, everyone, so that providing us the opportunity to go over cloud security. We have been working on cloud security, Guru and me, for quite some time. It's a privilege for us to present what we do to the faculty and the students. So I'll just switch over to the presentation, Dhananjay. All right. So this is a high-level agenda of what we will cover over the next about 45 minutes or so. We will just start with the basics of what actually cloud is, why we need to secure the data in cloud, and then we will get into a lot of details on how McAfee helps in providing cloud security. So, Guru, you want to get started with what is cloud?
I don't know if it's just me. I don't see your slides yet. Is it just me?
Actually,
Amit sir, blank screen is coming. It is black screen. Can you go to next slide, please?
I did go to the next slide. Actually, I am in the second slide, Dhananjay.
Okay, sir. I'm trying to remove your sharing. You start once again screen share.
Sure.
Yeah, try once again, sir. Close the PPT and once again you try.
Okay, can you see the second slide now? Yes, we can see the slides now.
It is visible now. Thank you.
All right. So over to you, Guru. Let me know how I should move along.
Yeah, sure. And once again, thanks everyone for having us today. Give this presentation. It's really an honor for us to do it too. As Amit said, this would be the agenda of today's discussion, where we first want to discuss what is the cloud, why we should secure the data in the cloud, and then move towards how specifically McAfee helps in providing security to the cloud, or the kind of applications that Amit and I work on and how they help in securing the data that enterprises add into the cloud. Next slide. Amit. Yeah, so we're going to use a few terminologies, although all these things may be, aware. Everybody must be aware of this, but I'll just go over it so that there's no confusion. So we're going to talk about enterprise software, right? So what is enterprise software and compared to consumer software? So consumer software is normally what is built for end users. For example, if you take McAfee, when you buy a laptop or a computer, right, it comes with an antivirus, or you go and purchase the antivirus product from McAfee. Now that's a consumer software because it directly impacts the end user. You install the software and it protects your systems. As compared to enterprise software, where it doesn't directly impact the end user, but indirectly does. And this is software that is built for larger enterprises. What I mean by that is, let's, for example, uh, take an example where you are using an online gaming software, for example. Now that software is actually hosted somewhere in the cloud, and that cloud actually has a lot of servers which is running that gaming application. Now those servers also need protection, and McAfee actually has software to secure the cloud or the data center as well. Now that comes under the enterprise software. So along the discussion today, most of the topics that we'll be talking about will cover protection or securing the enterprise cloud, not the consumer software. Next slide, Amit. Yeah, another thing that we need to make a distinction about, and this will help us with the continuity of the discussion today, is typical difference between data centers and the cloud. So a few years ago, everything was around a data center. A data center is where all your system, your storage, your network, your servers, compute, everything is within your organization's premises, right? It is within your organization's boundary with respect to the network, and it is locally managed by the administrators. There's no access to any of this from the external world. Now, over the period of time, data centers are now moving to what we call as cloud. So cloud is nothing but a remote data center, right? It's the same set of compute, network, storage, and all those services, except that you don't know where it is, right? It is in a remote location, and you have access to all of this through the internet, right? Provisioning, management, access, and all of that. And you also have a provider who manages all these things for you, right? So for example, if you take AWS, you don't need to worry about where your servers are existing. I mean, in the back, I mean, at the end of the day, they are residing somewhere in some AWS data center, but you don't own it, right? It is owned by AWS. You just pay for the services. So that's what we mean by cloud infrastructure, right? So you still have IT administrators in your organization, but you access all your infrastructure over the internet, and you just manage them, right? You just pay for it, right? How you provision it, where it is stored, and how you maintain it all gets taken care of by the providers. So that's the transition that we are seeing, most of large enterprises moving from data centers to cloud. And we'll, over the period of time in this discussion, we'll see why they would do that, and how security comes into this whole discussion point. Next slide, Amit. Yeah. So what are some of the customer drivers for cloud adoption? So we spoke about data centers and cloud, and why would customers actually want to go from traditional data centers to cloud applications? So if you take SaaS, for example, now, like software as a service, you can divide cloud into software as a service, platform, or infrastructure, right? So software as a service, you would now see more and more organizations use cloud-based software like Box or ServiceNow or Salesforce for their business purposes, right? Like for example, I want to maintain all my customer-related information in Salesforce. Now, I can do that very quickly if I'm using a SaaS application, instead of trying to have a similar kind of software installed on premises for me and go through the whole, management process, installation, upgrades, and all those kind of things. So that kind of gives me what is termed as business agility. It helps me drive my business faster. On the infrastructure side, again, I don't want to go through the same set of, again, maintaining an entire data center where I would have everything ready for me if I go to a provider like AWS or Azure, where I can just go, I want to start a new business, I want a set of servers, I need some storage, I can just go and provision all of that with the click of a button, right? So that gives me the speed with which I can even start a business now. And of course, for on the consumer side, for personal productivity, now you use Gmail, for example, right? Again, a cloud-hosted email solution, which improves your personal productivity, right? So these are some of the customer drivers why you see a lot of these and large enterprises move away from data center to cloud. Next slide, Amit. Yeah, so we've seen like 87% increase in business speed once customers move to the cloud. As we discussed from the SaaS apps, it gives you faster collaboration, faster time to market. If going for an infrastructure as a service through AWS, it helps you bring up your business much faster. And of course, personal productivity increases, and you see better employee satisfaction using shadow SaaS, right? Like things like Gmail, which is also cloud hosted. Next slide. Yeah, so this is where I stop about what is cloud. I think Amit, you can take over now and go to the next topic about.
Sure, thanks.
What we do. Yeah, thanks.
Yeah. So let's also look at why we need to secure the data in the cloud, because once we understand why cloud is important and how it helps us, let's look at few examples of recent breaches, pretty large ones, which happened. And like, for example, few examples to understand what really goes on if you don't secure the data in the cloud. The first one being, we know Marriott is a pretty big hospitality chain, and they suffered another breach. This was not the first breach. They suffered one more about 2 years back. And in this one, they actually lost about 5.2 million guests' personal data. And that was primarily because of some employees' credentials was somehow stolen, and then the hackers got in through credential stuffing and phishing, most likely. Or another example is about an Antheus biometric data breach, where about 75,000 plus users' fingerprints data was stolen, where the mistake, if you look at it, was very simple, and it's easy to analyze that in the hindsight, that the company neglected to password protect a database on the cloud or properly encrypt it, and that's how hackers got access to the fingerprint database, and they could access thousands and thousands of records. Couple of other examples, and then we will understand this a little better. So EasyJet, one of the low-cost large airlines, had a highly sophisticated attacker and steal information for about 9 million customers' personal data. They eventually got a class action lawsuit under GDPR for about 18 billion. And what you can see is that the hackers were actually behind the company's intellectual property. And if you see what hackers are looking for, right? Hackers are looking for email addresses, names, travel records. And once they get a hold of this information, those users are now vulnerable to phishing attacks and more aggressive targeted attacks based on their travel history. Given that you make payments online as well, you can see that about 2,000 plus customers had their credit card details exposed, including the CVV code, which is at the back of your card, right? And therefore, which could lead them to theft. And the last example, which is more relevant in the COVID times, given that we use video conferencing facility a lot more, Zoom had a loss of about 500,000 passwords sail on the dark web. What that means is, and we know that we use multiple cloud services, each one of us, and it's very hard to remember passwords for all those different services we use, and the general tendency is that we use same password in multiple places. Now, if your password, let's say on Zoom, is same as multiple other places and it's stolen, then you are actually exposing the risk for multiple other sites and so on. So these smaller issues actually, in a very large scenario with a very large set of companies, actually can blow up and expose your personal information, intellectual property, or financial information like credit cards and so on, which can impact businesses from the operational per se, and as well as exposing the data from customers' point of view. So so what we will do is, over the next course of about 40 minutes or so, we will go over and understand each of these different aspects on how we can secure that data in the cloud. And for example, what you can see is that there is an need for securing, let's say, your sensitive data in the cloud. And before we can even get there, we need to understand where is my sensitive data stored in general across a lot of customers we work with. So we look at the distribution, and it's actually across your SaaS, IaaS, and other services like Guru pointed out. So you see Office 365 usage over cloud has been increasing pretty rapidly over past some time, or a huge amount of data is saved in Salesforce or ServiceNow or AWS or Box, right? So it's actually few services take a lot more data, but then the data is actually shared by a lot of services and not just few. So like Guru explained, what happens is your network controls which you had within your premises or within your firewalls, right, don't really work when you are in the cloud model, because those security infrastructures don't come into the play as you are moving your data away from your firewall or control to the cloud, right? And it could be SaaS or IaaS, PaaS or anything. So what we have seen is about 95% of the traffic actually is moving to the cloud, and then there is another set of variable where it's a cloud to cloud traffic. So for example, you have data in Box. Let's say you store your document in Box or Dropbox, and you want to start collaborating with your peers, and then you think that Google Drive gives you better options. So you actually move your content from Box, like drag and drop them into Google Drive in some sense, and therefore you are actually doing a cloud to cloud traffic for better productivity or collaboration, right? So the understanding is that your network controls can prevent what's within your firewall, but if it moves beyond that perimeter, then you need to look at different set of controls to protect you against the security and the breaches. And initially, a pretty good example was given by Dr. Prakash, where he said that it's like a bank versus I have a responsibility and bank also has a responsibility. So this is some sort of that corollary where we say that there is a customer responsibility and there is a service provider responsibility. And if you look at it, it varies depending on the service you're using and how much depth you need to get into the security model asset. But the easy interpretation is, even if you look at it not by looking at how much you need under IaaS versus how less you need on SaaS, is that data classification and accountability is always customer's responsibility. So we cannot say that when I'm losing my data because of I hosted it on AWS or Box or Dropbox or Google Drive, we cannot blame Microsoft or AWS for that. It's a shared responsibility model where we also need to take care of the options provided by the vendors and providers so that our data is secure. And like one of the leading analysts, Gartner, said, and this is a couple of years dated, but it still holds true, that through 2020, 95% of the cloud security failures will be the customer's fault. So while we understand now what is cloud and why we should secure the data in cloud, let's understand how McAfee helps in providing cloud security. So what we will do is we will go over different types of solutions what we provide, and not get into too much of detail, but keep going back to the point of what data is present where and how you can actually secure it at a very, very high level overview. So going back to the same example which Guru presented, so what we're saying is your different devices are connecting to SaaS, IaaS, or Shadow different services, and McAfee's mVision Cloud or the cloud solution actually helps you protect. Now, if I would at a very high level segregate that I want to protect data, I want to first understand what is my visibility to it, right? So what data is present, where it is present, who's accessing it, when is it being accessed, which devices are accessing it, what applications are present, how many users are using. I need a lot of visibility around it before I can actually craft and devise policies to control that data and control what should not be there and what should be prevented, right? So there's a whole bunch of visibility aspect around it, and then based on the visibility you can take a better uh, shot at what you can actually do to control, right? So for example, if you have sensitive data, you can go ahead and define DLP or data loss prevention policies, which can look at sensitive content in your cloud and actually go ahead and do something about it. For example, if I have proprietary content in the cloud, then should I go ahead and delete that data, or should I move it to a separate quarantine folder which only certain administrators have access and the actual data is moved away from its original location? Or should I go ahead and encrypt the data with a different key and only certain devices can access it, for example, right? Or if you are, let's say, using S3 bucket in case of AWS or a database to store the data, have you taken necessary controls and precautions while configuring that bucket or configuring that database, for example, like you saw in the context of a breach a few minutes back, right? So these are the different types of controls at a very, very high level on what you would need to protect the data. And then before you can protect, you also need to get a high level visibility of what exactly is your exposure to the cloud. So what we do in the solution is if you look at this graphics bottom up, then we understand this from the framework where we have created a common security services framework where you can classify different modules or different blades to that framework in the context of data protection or threat protection. And under data protection, we just talked about DLP and as in data loss prevention, encryption, classification, and so on. And then there is a threat protection angle where you can say that there is a user entity behavior analytics, UEBA, or malware protection, or monitoring which activities are happening from which location. So for example, an example which one of our customers reported, the automotive customer, when they used to create newer documents, they very often figured out that their designs were leaking, and actually they eventually after a lot of analysis figured out that it was being leaked from some other place in geography where people were accessing it, and they did not have enough controls to prevent such access. So activity monitoring in that sense helps you see who's accessing the data and whether that data should be accessed from certain locations and so on. Once you bubble up the framework from data protection, threat protection, what happens eventually is at a high level, you start providing features like compliance and risk assessment, reporting, and then orchestration to prevent all of it. And this framework applies to all the SaaS services and IaaS services and shadow apps like we've been presenting in earlier slides. And this is again the similar example where it says that the SaaS, long tail SaaS applications like, for example, Dropbox or like Jive or Workplace or Ignite, or enterprise SaaS, which is more like a sanctioned applications like Office 365 or Box or ServiceNow or Slack or Teams or SharePoint, for example. So the application of preventing the data, irrespective of whether it's a long tail SaaS or sanctioned enterprise SaaS, the security is needed for all of those services. And now we will start getting into the individual blades of the feature, not from the building blocks as such, but from a customer's point of view, how they see the features and what actually each of these features provide in the context of visibility and control. So the first one, let's say, is shadow IT. So what is shadow IT? Shadow IT basically means that I am trying to use an application, but I'm not basically dependent on my IT administrator. So for example, if I want to use Box as my application, or for example, SharePoint or OneDrive as an application, I don't have to get an approval from the IT department or IT team to be able to. I can just go create a username. If I want to use advanced services, I can actually purchase those services by paying through credit cards, and I have access to technically the Box or AWS or Azure or any other service in the cloud, right? And I'm actually bypassing the IT. So that which way it's got coined as shadow IT. And when we started long time back, we figured out that it is a major problem. On an interview, generally we ask customers that, do you know how many different cloud apps you think employees are using, right? And that number used to be in the range of about 50, at most 100, depending on the organization side. On average, it was actually less than 50. But when you actually do the discovery, where we did the discovery of what was shared, we figured out that number is not about 100, but it's close to 2000. And we also reported saying that about 10% of those services are actually high-risk services. So what we are doing as a product is giving you the visibility of what is being used and whether it's risky, as in on the scale of low, medium, high, or on a scale of 1 to 9 from a risk score per se, what are high-risk services. And this is a trend which has gone just on an upward over a period of time. And we started about in 2013 with the Sky Networks, which started with the cloud security shadow IT as their first product. And over a period of time, this eventually has been increasing. And we don't have the data for 2019 in this slide, but it is higher than this, which we reported in our cloud adoption report. So what really happens with this shadow IT as a problem, right? So if you are accessing high-risk services, for example, let's say torrent sites, right? Then the question is, while you are using torrent sites or anything to share, let's say convert Word documents to PDF or PDF to Word, and you can actually go look up for some converter and upload the document. You don't really look at the terms and conditions of that provider on whether they actually will own the data once you upload the data for even conversion, right? And those terms and conditions are fine prints, as you would expect, and we don't read those terms and conditions usually. So what happens is, once you upload a PDF file to convert to Word, there is somewhere a fine print which says that any data uploaded here or any image uploaded here, we will own the right for it. Now, in that context, who will help us to prevent accessing such services, right? And you are not going through IT. So what can IT do? IT cannot do anything because they don't even know about it. But with this solution, what really now happens is, now with the McAfee solution, IT can say that, no, this is a high-risk service, or this service actually is something where you should not upload data because you will lose the ownership of that data, right? And they can actually block access to such websites or services through, let's say, the firewalls you have placed in your infrastructure. So anyway, to access those services, when you go through the internet, you go through those firewalls. The rules can be implemented on those firewalls to prevent access to such services. And you can actually, let's say if I block access to one of these services, you can find another one, right? But then the idea is not to allow, not to block customers or users from accessing sites. The idea is to suggest an alternative, saying that, no, this is not the right one, but instead, why don't you use this for if you really want a conversion, or if you want to really share large documents with your friends and colleagues and faculty, for example, right? So that is the enablement what we provide in the product, by saying that there can be conditional access control, there will be prevention and alternatives suggested, and then there is a data loss prevention angle to it, where we can say that once you upload the data, do we allow you to upload if it's sensitive content based on the policies which you define in the product. You can actually go scan the content against those policies and appropriately take an action of whether you want to just alert or whether you want to go ahead and delete or quarantine the file, for example. So how this works at a very high level is we have a component which we call as Sky Gateway. So this is a installer which you can install in one of the virtual machines, and it takes all your logs from firewalls or proxies or wherever else, and it passes those logs and sends an analysis and the parsed data to Envision Cloud to give you the visibility of whether you are actually using 100 or 200 services or whether you're using 2000 services or more. And that also tells you how much you are uploading to those sites and how much you are downloading from them, what is the risk score of the site, and so on. And then once you have that visibility, you can actually go ahead and apply certain controls, saying that I want to allow access to these marketing sites only to the marketing department, for example, or I want to allow access to social media sites only outside of let's say work hours, right? Or you can control what data can be uploaded using the DLP policies. So to summarize, what is our differentiators compared to a lot of other products in the market providing cloud security? Our solution has a very good breadth and accuracy of the registry. By registry, what I mean is that you have more than 30,000 cloud services in the registry, which is what we compare against. And when I say why it's only 30,000 and not 100,000 or so, because each of those entries are manually curated by a team here, and each of those services are evaluated on 50 different security parameters to actually go and read those fine prints, read the terms and conditions, understand how the data is uploaded, how much you can upload, whether it is good to allow uploading of data or not. And there are different parameters on that, right? So once you go through that, we assign a risk score, and that gives you the visibility on whether it's a high risk, medium risk, or a low risk service, for example, and therefore alternatives can be suggested. This solution does not allow you to replace or change any hardware. You can just pipe those logs to the Sky Gateway solution, which will actually keep processing them parallelly without getting in line, and give you the visibility through the McAfee Envision Cloud Console. I'll switch gears to a different solution feature blade called Collaboration SaaS Security. So similar examples of how users use the cloud, right? So you actually upload a file and you want to share it with your friends. It's very easy to share files on SharePoint, OneDrive, Box, practically any other cloud storage service, if I would say. So 22% of the users usually share files, and 48% of the sensitive data is shared over time. And that is pretty striking, given that there is sensitive data, and on top of that, it is being shared. So if I actually do not provide or apply controls to the data in the first hop, and if you go share it with someone else, he could actually go and share it with someone else again, right? And then I actually lose control of where the data is traveling, and the sensitive data is beyond something which a product can control, right? So the importance is on evaluating the sensitiveness of the data as soon as possible while you go ahead and deploy the solution with the policies and so on. And the last point again being that 21% of the files are accessed within few minutes, as in 5 minutes of being shared. So you know that I am trying to tell you that, hold on, Guru, I'm going to share a file with you, and I just click the share link, right? And he immediately gets it, and then he accesses it. Now, how soon can I prevent, oh, by mistake, I shared something which I should not have, right? And that's also a problem. So going back to the data protection of those sensitive data which was uploaded either intentionally or by mistake, which was shared, has to be controlled through defined data protection policies, which can be actually executed in full scan mode or in real time mode, so that you can actually prevent the data before, let's say, my colleague Guru can go ahead and access it. Then there is a different problem about accessing and let's say malware sprawl, right? So if, let's say, by mistake there is a malware in the cloud and I go end up downloading that file or a document or object, I'm actually downloading it on my device and I'm actually doing other operations and spreading that malware, for example. So what you would expect is that if the file is infected with malware in the cloud, you want to actually delete that file or quarantine that file which is infected, so that it does not go to multiple devices from then on, right? And then the third part is contextual access control, which actually means that if I want to share a file with you, uh, can you access it from any device, or are you allowed to access from company authorized devices or devices which are, let's say, managed by your IT, for example? So why that's important is that if I have my data and let's say I on my phone I'm accessing my emails and documents, and let's say I'm using that phone for my personal and office use, which is what I do, then if, for example, for whatever reason, let's say I lose my phone, right, or I'm exchanging the phone and I don't wipe out the data, and if I don't have necessary controls, I'm actually exposing not only my personal information but my confidential information from my organization when I'm doing that, right? So the idea here is to allow contextual access only to the corporate devices and not personal devices. Otherwise, they are being managed through the IT, for example. So what we do again is going back to the visibility and control model of saying that where is the data across the devices and the cloud, and what data is confidential, and how you can actually, once you analyze the data, how you can do a unified management of the data using the McAfee product. So you want a single policy, let's say, which works on confidential data in the cloud, as well as, let's say, confidential data in your laptop or in your tablet or on your, let's say, mobile devices, right? And the policies have to be applied generically everywhere, so that you don't have to go and define different policies. You don't want a different policy, let's say, in general for scanning your content in Office 365 versus scanning the confidential content in, let's say, AWS S3 bucket. So you want a unified policy, unified console, unified incident management across all of it, and therefore it is device to cloud data protection against unified policies. This repeats the similar model by saying that it's the same DLP engine which does the scanning and classification, and one location for all the incident management and remediation, irrespective of where your data is on the devices or on the cloud. So the last bit here basically is about real-time access. The Lightning link is a feature which we support, where if I'm sharing a file with Guru, the file will not be shared with Guru until it is scanned through the Lightning link feature, which means there is an inline evaluation of sensitive content of the file before the link actually reaches Guru's inbox, right? And that actually prevents the file being accessed, given that we saw that 20% plus users access the file within first few minutes, right? And if there is, let's say, sensitive content, the control could be to block or revoke collaboration itself directly, and he will never receive the file because we said through the policy, and we detected through the policy saying that the file had sensitive content. Okay, couple of other slides before I hand off to Guru. is usually what we have seen is depending on the organization's size, there are lots and lots of alerts created, lots and lots of triggers being created. And what that means is I, as a user, cannot keep doing things in the wrong fashion and hope that IT will come, or a security analyst team or security operations team will come and fix all the issues, because the security operation team is of fixed size, and while the number of users are usually much larger than the security team size. So what we do is we provide automated remediation. In case of autonomous remediation, what we have workflows is to coach the user while asking the user to go fix the issue. So for example, if I'm sharing a file, going back to the same example with Guru, which has sensitive content, I will be notified instead of, let's say, the IT admin saying that my file had sensitive content. I need to take care about it. And therefore, I also learn in that process that I should not be sharing it further. So it does two things. One is that it offloads the work away from IT administrators to the users, and it also coaches the individual users to not repeat similar actions in the future, because they understand that this is something which is in best interest for employees as well as the organization. This repeats the same thing in the context of SaaS security, where you can, I just said, managed devices, let's say, can access, versus unmanaged device will not be able to access, given the control policies we added in the product. Why we emphasize a lot on the frictionless data protection? So frictionless, in some sense, could mean at a very high level API based access. So if I am not going through a proxy and adding a hop to your data between the user and the data, then what I am doing is I am actually setting up an API access to, let's say, Salesforce or Box, and creating a parallel path so that I can go scan the data as soon as possible without getting in line, so that I don't affect the operational experience as well as I'm not in the path in case if my service goes down, you are not able to access Salesforce or Box or AWS, for example, right? So the frictionless is very easy to deploy. I can go set up an API access and go ahead and run those scans and actually do something about the data in parallel, as close to real time as possible, by applying appropriate hooks. And it is easier for customers to try it, easier for customers to implement it and scale it up, and it is user friendly, user centric. No delays are added in that process. Guru, you want to go over business as and a couple of other sections?
Yeah, sure. Yeah, thanks, Amit. Yeah, so the next section, or the next blade, as Amit termed it, would be classification of these cloud services into business SaaS. So business SaaS, if you remember, the first slide that Amit shared was mostly, applications used by enterprise for their business agility, like, Salesforce or ServiceNow, right? So Salesforce, again, is a CRM, customer relationship management, where there is a chance that you have sensitive information on these services itself, and very much so from what we have found so far, right? So there is information related to which customer is purchasing your product, who is your probable customers, how much money he's paying for it, and a lot of those kind of details which are sensitive and to your organization is kept there. Also, so what are some of the use cases when it comes to the business SaaS application? So first of all, like any other section, we also need discovery, visibility into what has been stored there. So where does your confidential data reside within these applications? The next use case that you would want to solve once you find them is this data protected or not, right? So how do you protect it? Is this data encrypted, or is this data being exfiltrated? If so, how do you stop it, right? And how do you overall provide threat protection to these services? So these are some of the use cases that we want to solve from the business SaaS applications. And how does McAfee solve it? Again, as we have seen, most of the architecture is uniform across all kinds of services. Like Amit has already explained what is a Skylink or what is a McAfee Sky Gateway, right? So if you see, the overall architecture remains the same, but there are some subtle differences between how we protect different services based on the use cases. Right? For example, business use cases, a business SaaS application where you store sensitive information requires encryption, and McAfee provides that ability. And also the key differentiator, or one of the things that McAfee does, is it's able to integrate with an on-prem or a key management system which the customer owns, right? So here we are not applying keys or encryption from the cloud, which, let's say, can be compromised if we are compromised, for example. On the other hand, if the customer is um, wanting to use his keys or his key management software, we can extend the same by leveraging what is shown here as ground link, where we are able to connect to his key management software, pull up those keys, use those keys for encrypting the data that is present on your business applications, right? And that's how we provide control to the data that resides there, right? And also another important aspect here is most of this data from the business applications downloaded as reports. Now, you wouldn't want these reports to be visible to anyone, or like Amit shared in the previous example as well, it would be only on managed devices or devices where it is supposed to be opened on and not on every other device. And that's where DRM, or digital rights management, comes into picture, and that is applied on the downloaded report. So all these features are provided so that you can provide control or visibility and control on the business applications. Right. So as I said, most of the reporting, right? So this is what typical Salesforce compliance report looks like in the McAfee portal, where you are able to show how many of we can classify it into high, medium, low severity incidents that we found, how much of data resides there, and things like that, by giving a good dashboard of compliance. That is the reporting. And after that, we apply remediation techniques, which we already discussed, right? Encryption could be one, deletion could be one. So all these are defined through policies. And like Amit said, we have a uniform policy framework where you define a policy, and the same policy can be applied on different services. For example, I can say that, hey, if this data is going to be this certain content has so and so thing, go and encrypt it. Or if something is there which should not be, I can say go and delete that data. So all these kind of things can be defined as a policy and be applied as remediation, right? And these checks are performed on a regular basis, is what we call the on-demand scanning, which is we have a framework where you can say that I go and scan my Salesforce every 24 hours. So that framework provides mechanism for you to go and run all those policies which you have defined every 24 hours or every day or every week, and generate these kind of reports for the customer to view and analyze how compliant his service is, or how compliant he is, with his cloud service that he is using. Yeah, so from the business SaaS apps, some of the differentiators that the McAfee product provides is, the data exfiltration that we spoke about, right? And how we are able to integrate with an on-prem key brokering system. That is, you have a key management software and you manage the keys as a customer, but we are able to integrate with that and use those keys to encrypt your cloud, the data that resides on your cloud, right? And of course, like you saw, we have very good compliance reporting for all the data that is stored, whether it is structured, unstructured, at the very minute level of fields. When it comes to Salesforce, you can define a lot of objects. It has parameters, attributes, and fields. You can go up to the very granular level and provide reporting visibility on all the data that resides there. Yeah, so the next section, I think Amit briefly covered this, is what we call long tail SaaS. Now, long tail is the terminology where we use where, it's not, it's on the lower side. If you remember, there was a graph which, peaks at the beginning and then tails at the end. So these are some of the services which are not commonly used, but not to a large extent like, Office 365 or Box, which is, on the higher side of it. Now, enterprises use long tail SaaS apps a lot, and it becomes absolutely necessary to provide extend the same capabilities that we provide on enterprise applications to long tail applications as well, right? Because you may be using something like Microsoft Teams or Workday or Facebook for Business. Not all enterprises use this, but some of them do, and it becomes important for them that we secure the same solution that they're using for Box can be extended to these apps as well. Now that capability is also present in this whole Envision Cloud architecture, and we extend the same set of services like what we had using the Skylink, for which we used APIs to connect to enterprise apps. We are able to use something called CASB Connect, which is our universal API connector to connect to any SaaS. So if you see, it doesn't mention long tail, or we extend it to any SaaS application tomorrow. So if it supports API, so we have a pretty cool connector framework where you can define what are the APIs that you need to connect to, and using that connector, we can extend all the policy capabilities, scanning, remediation, encryption, all of that to any application. So this is what we mean by extending it to the long tail SaaS applications. And some of the key things here are, sorry, if you can just go back to the previous one. I just want to mention that it takes only about 2 hours to complete the entire integration. So if somebody comes up with a new app, new cloud app that they're using, and they say, I want to extend the McAfee services to this app as well, it takes at most 2 hours for you to build that connector and extend the entire framework to any SaaS applications. So these are some of the examples of long tail SaaS apps, and Dropbox, some of the things you might be already using. GitHub, for instance. Okay, so the last section that we want to cover in this entire sphere here is the IaaS services, or the infrastructure services. Now this actually is the second largest, if you see here, 24%. And in the introduction, we had seen how important IaaS services are to an enterprise customer, right? So it helps in speeding up the entire business process. Like I had explained on, if you want, even for smaller organizations who want to, build their applications faster, it's much easier on the cloud, where you just go click a few buttons, pay the money, and you have your entire infrastructure set up. Now that works well for smaller orgs, but we have seen a lot of large organizations whom we have as customers also move to these cloud providers for their infrastructure solutions. Now, it's very another point before we go into this is, if you remember the shared responsibility model, which Amit spoke about, IaaS had the highest, the most number of sections where the customer is responsible for configuration, and only one small section which the provider is responsible for. So it becomes very important for the customer to take care of all the parameters for securing his infrastructure. You cannot depend on the platform, or you cannot depend on the infrastructure provider. So that reflects here on with these numbers that you see, that there are at least 14 misconfigured IaaS services running at an average for every company. And so if you're using AWS, for instance, you'll be using a host or a whole lot of services to build your infrastructure. Like you use compute, storage, you want encryption, all kinds of services that you'll be using. And what we've noticed is that this is an average, right? You see 14 of these services are not configured properly or misconfigured and prone to, anybody misusing it. And this is another, number which is staggering, because 99% of these misconfigurations seemingly go unnoticed. And here we're talking about it goes mostly unnoticed to the customer, not to an adversary, right? Because he's actually looking out for these kind of misconfigurations that you have so that he can exploit it. And when it comes to data loss prevention, also we've seen more and more as you move to IaaS, you start using the storage there, and you start putting a lot of your data, which includes sensitive content, also onto these storage services. And now that, as you know, there's nothing much given to you by the provider. I mean, he just gives you the tools to secure it, but he doesn't secure it on day one. It's up to you to go and turn a few screws and make sure that everything is fine. So that results in a lot of data that we see sensitive content has been put there, which we detect. Right now, it's very risky because, as you see, some of the services are not misconfigured or not configured properly. They may be open to the public, and now it provides a channel for somebody to get access to this sensitive data and misuse it. Amit, next slide, please. Yeah, so what are the key use cases that McAfee tries to solve when it comes to IaaS, right? So again, you have to go through the same kind of things like visibility, misconfigurations first of all, right? So how many of your services that you're using are non-compliant? As in, this, how we do is there are a standard set of benchmarks and best practices as to how to secure your infrastructure, and we have configured them as security policies, and we go and check every single resource that is present in your infrastructure and see if it has been configured properly or not, right? So that gives us a visibility into non-compliant resource, and then we are able to say that, hey, this particular resource that you are using is not using so and so settings, so go and fix it, right? And again, advanced threat protection, like privileged user threats or malware. You can also have malware on your systems on the cloud, right? We should be able to detect that. And finally, from a data loss prevention point of view, is any of your confidential data residing in the cloud infrastructure services that needs protection. So we provide visibility into that through DLP. We provide advanced threat protection through our threat protection platform, and our audit platform provides helps us address the first use case. Yeah, so how do we do that? Again, as you see, most of the infrastructure here remains the same because it's a common framework that Amit showed in one of the slides, where you had a common framework, you have different blades on it. So most of the underlying architecture remains the same. And of course, AWS, Azure, and Google Cloud, they're all API rich. They have to be, right? So, and we leverage these APIs to be able to extract data from the cloud. And these are all managed services. Managed, by managed, I mean customer grants us access for us to be able to go and perform all these actions on his accounts. So by doing that, we are able to extract all the data that we need, apply the policies, and give visibility into what is not right. And then we apply the controls, right? For example, I can define a policy which says that if I have a network that is open to the public, or if I can SSH or to an EC2 or to a virtual machine from the internet, right? I was not supposed to do that. I need to restrict it. I should not allow public SSH access or an RDP access. Now I detect that, provide visibility, and through the policy I can say that go and block that access, right? Go and set that IP to something else, to my private network, so that nobody outside my VPC or my VPN can access it. So those are the kind of controls that we can provide for misconfigurations. DLP, of course, the same DLP that we applied on SaaS is extended to IaaS as well, by which I mean, if I have defined a policy that says detect my confidential content in box, right? Now, I don't say in box, I just say go and detect confidential content by giving some rules. And the same policy, I can apply it on my box account, I can apply it on my AWS account, or I can apply it on my Azure account, and it detect, the mechanism remains the same. I should be able to detect it. So we have that's the way to provide a DLP on the storage buckets. And threat protection, of course, we do a lot of activity. We collect a lot of user activities from all these cloud services, which I think Amit briefly touched upon earlier, where we collect a lot of data based on user activities, and we're able to detect threats. We are able to model anomalies and threats based on the activities that have been collected. For example, Amit gave a good example where, I have a my entire employee force is, let's say, based out of US, and I'm accessing the AWS account, so a lot of AWS accounts, and suddenly I detect that there is somebody who is trying to provision an EC2 instance or access some data from an S3 bucket from, let's say, China or Ukraine or something like that, and we are able to detect that, and that comes in as an anomaly, and we can block that access as well based on certain policies. That's the kind of visibility we can provide in threat protection based on user activities and user behavior, right? Right. So we also have, like I said, most of the access is through managed devices. We can see that the requests coming in are from managed devices or unmanaged. We also have, I think managed and unmanaged here is referencing to who is accessing it. We also have access to managed cloud versus unmanaged cloud as well. Yeah, so this is another important thing that we introduced recently, which we call shift left, security to reduce risk. And this is more to do with how infrastructure is deployed today in the enterprise, right? So if you see the typical life cycle of development of a software, you plan, you code, you build it, you test it, and you release it, then you deploy it, and then you have an actual running application in production, right? Now, most of these detections or the security software actually runs on applications that have been already deployed, right? Which is already running. So I have my production servers running and I have audit checks running on that. Now this is fine, but I already have it deployed there and I'm doing it after deployment. So one of the cool things that we would do is try to detect these misconfigurations even before it's deployed, right? So that's what we mean by shift left. So we can do it at multiple stages, right? So even before you deploy it. So on the infrastructure side, most of the deployment is not done manually nowadays. It's done through what are called as templates, right? All these infrastructure, so it's called infrastructure as code, right? The entire infrastructure can be templatized. For example, I can define that my production infrastructure needs to have 10 virtual machines, so many security groups, one VPC, and a load balancer and things like that. Whatever I need can be defined as code. And each of these vendors, like AWS, provides a template mechanism to do that. Now, there is a developer or a DevOps engineer who's actually sitting and writing these templates. And while you're writing the template itself, you can, you can misconfigure it, right? For example, whether or not to block SSH access to public internet is somewhere mentioned in that template file. Now I can detect that even before I actually go and deploy it into production. Right? I can actually scan the template file itself. So that's the kind of visibility we want to provide even before you deploy it. So if we detect misconfigurations in your template itself, we stop the release process and say, hey, this thing cannot be deployed unless you fix it, right? We don't need to wait till it gets deployed in production and then go and check it. And that shifted over a little. If you shift back a little more, so this is at the deployment stage. And if I go one more, if I shift left a little more, I can do that even before the developer checks in the code. Now, most of the code is checked into, let's say, a source control repository, and I can sit there today in between him and the code repository and say, wait, don't check in that code because you have this misconfiguration. So we have shifted this entire check from doing it on a production server to before the developer even checks in the code. Now this became very important because once it's deployed and you have end users using your infrastructure for whatever, you may be a large enterprise providing a solution. You may be a SaaS solution yourself, and you cannot afford a downtime, right? So now if I detect that, hey, you have done so many misconfigurations, now he has to go and correct it, and that's not something that he can do with a switch of a button, right? He needs downtime. He needs to bring his service down. He needs to do a lot of changes and bring them up again. Now, if you do it at this stage, wherein you're doing it where before the developer even checks in the code, there is no impact to whatever has been deployed, and developer just checks the report. He says, oh, okay, this is what I need to fix, checks in the code, and then the release cycle continues. Yeah, so from McAfee software point of view, what are the different key differentiators that we have on the IaaS product is we support multi-platform. We support AWS, Azure, and GCP today. We do preemptive and continuous risk analysis. Preemptive, like I said, even before it's deployed, and even after it's deployed, we do continuous checks based on events. And again, it's developer centric, like we just discussed, right? So it's easy for a DevOps engineer to use our product. Yeah. So Amit, do you want to summarize? And I think we are done with all the different sections.
Yes, thanks, Guru. I'll just probably go through the last couple of slides. I hope we have not put everyone to sleep. So we provide, therefore, 100% security coverage across different types of services, like we've been calling out repeatedly over the session. And this has been given enough accolades from multiple analysts over the period of time, and there are a whole bunch of logos which you can see who are our customers who use our solution. And I'll just summarize the presentation with this last slide, where we say what is needed, right, from the security per se, as how I would say prevention is better than cure. So at a very, very high level, if we go back and say that what are the three key things I would look back, right? I need to secure my configuration, I need security of my content, and I need to prevent threats. By configuration, we mean that you add appropriate guardrails to your IaaS, SaaS apps, wherever they are, so that you can prevent breaches and vulnerabilities. You can prevent access to risky services and applications. And you can enable multi-factor authentication, let's say, with a strong password as a very simple mechanism to prevent access. And just last week, it happened that somebody from Malaysia tried to access my personal Outlook account. And because I had MFA enabled on it, obviously the person could not get in. So looks like that password was leaked, and it was a common password used for multiple services and so on. So before I can go and change my password, which I did next day, multi-factor authentication technically saved me from letting anyone access my inbox. Going back to the DLP or security of content, which we have been repeatedly calling out in every section. So we need to be mindful of what is confidential and what is sensitive, and whether it should be available in the cloud, whether we should be encrypting the data, whether you should be allowed to download it to certain devices, when you should share and when you should not share what you have in the cloud. And you can also add, for example, general and simple expiration time to it, saying that I want to share this document, but the link expires after 3 days, for example, right? So you, in some sense, prevent sharing further, and you also can control that it's not available infinitely, right? And the content also, not just because of it being a sensitive content, the content also should be checked for malware and viruses before you can actually download. So for example, you have seen that when you have attachments sent via, let's say, Gmail or different mail services, they actually go scan the content against a virus scanner or malware scanner before they allow you to download, which is something which is turned on by default, and it's in some sense mandatory, right? So things like that, a couple of providers can provide, but then if you are having and using multiple cloud services, this something is needed across all the data on your cloud, which you are, let's say, downloading or even in some sense uploading, so that you don't upload it to the cloud as well. And the last part about threats is you need to control who's accessing your content from where. For that, you will also need to monitor activities and identify if there are anomalies or abnormal patterns which you can gather from it, and therefore you can infer it to be a threat and take appropriate action, for example. And there are different types of threats via phishing or via remote code execution, which can actually be done in your product or in your software when you deploy, right? So we need to be mindful for a bunch of things so that we can actually use cloud more easily and be secure with the data what we have on the cloud. This is the last slide we have. So Dhananjay, how do you want to take any questions from anyone, or how do you want to go and proceed further?
We request any of the participants to post the questions so that the speakers will be happy to answer you all. You all can post the questions in the YouTube chat box. Participants can post the questions.
Yeah, probably there are no questions from the participants. Shilpa.
Yes, sir. Satish, sir. Sir, you're on mute, I think, sir. Satish, sir. Satish, sir, we are not audible. You are not audible, sir. Sir, your voice is not audible, sir. So there is a one question from the participant. I will be posting it.
Yeah, I can see that question. It's about whether symmetric or asymmetric. Guru,
Yes,
you want
sir.
to take that? Guru, you want to take that question of whether symmetric or asymmetric encryption is more secure?
Well, I don't know what's the context of the question. Are you saying do we apply symmetric and asymmetric encryption technique in the cloud? I think yes, we do both.
Any other question?
So there's a question from Dr. Satish on the private chat about asking ML-based cloud security. So I'm not sure if I understood it right, Dr. But I'll take a guess at what you are asking. So what we do is the threat protection piece in our product today, where we actually ingest the activities. What we do is, after ingesting the raw activities from those cloud services, we actually infer whether there are anomalies, and then we actually map those anomalies to threats. And that's the progression. So from activities to anomalies and anomalies to threats. The path where we move from activities to anomalies and then to threats is done through our machine learning UEBA engine. And that is where we actually identify. So when we call out something as, let's say, a privileged access threat or a superhuman anomaly or insider threat, it's referring to that.
So we have one more question, which I've posted it on the screen.
Guru, I think the question was, which is more secure, symmetric or asymmetric?
I don't know how to answer that question. Do you want to take that? I mean,
No, I don't know the answer. I mean, we actually, Hina, we don't really apply the encryption on our own. I mean, we ask the customer to choose what encryption algorithm they want to use, and we actually, in some sense, broker the keys through our solution. So it's up to the customer to decide what makes more sense for them. In our solution, go ahead, Guru.
No, I was just saying the same thing. We don't suggest either. As in, there is no distinction about what is more secure. It's up to the customer to select what kind of keys he wants to use.
Okay. There's one more question about how do you protect access to GUIs and APIs. So we don't directly prevent access to GUIs. I mean, if you let me elaborate that question a bit, right? So, for example, if you are saying that I have a cloud service called xyz.com, and do you want to prevent access to it? Yes, you can prevent it. If it's a risky service or not, you can create a rule in the firewall and prevent access to that service itself. If you don't want to prevent access to the entire service but prevent certain actions on the site, for example, you don't want to allow people to post on Facebook, but they want to see, so you can do those granular actions as well. At the API level, we don't have a very elaborate solution to provide security. It's a completely different domain to control security at the API level. So API security is a completely different domain, which we don't yet provide solution for, if you're asking that. Guru, you want to add anything to that?
Well, so if your API is actually hosted on the cloud, right? For example, if you're using AWS API Gateway, for instance, we do provide security to that specifically. I mean, we can secure the API Gateway configuration, but internally, if you have a service which is running on an instance and you're hosting an API there, now that's a totally different use case, which we do not handle today.
So we have one more question in the private chat by Satish sir. It says cognitive security, referring to cognitive security.
I am not sure about that, Shilpa ma'am. I will probably get back to you or Dr. Satish offline.
Yes, sir.
I think there's also
one more on the comments box about Twitter accounts getting hacked even after they have good security. So how are they getting access to it? Yeah, it's a good question. If you ask me, and I don't know a very good answer to it, but what I do, and I think most of us do, is let's say if I'm using on a rough scale about 20, 30 cloud services, I don't have 30 different passwords. I use similar password in multiple places. So that which way, if you are not, let's say, enabling multi-factor authentication, or you are not setting a strong password, and let's say your password was leaked through some other site which is not Twitter, then you technically end up exposing your Twitter account also. Yes, for the next question, in Salesforce, scanning is done for sensitive data irrespective of the size of database. The answer is yes. We do support structured and unstructured data scan, or DLP. So irrespective of the size of database. So I would not see it as a database. So for example, in the context of Salesforce, what happens is there are multiple fields, and then in the scanning configuration, you define which fields you want to scan for, and we also provide the granularity of which fields you want to scan with what algorithm and what policy. So it's not a brute force database scan of Salesforce, but it is at the field level. But yes, it is irrespective of the size of the customer account or Salesforce account.
Also, going back to the previous question, Amit, with respect to Twitter and things like that, sometimes it's also a case of insider threat and somebody leaking the data from within, and how these passwords get compromised, right?
Right. Yes. Okay. Guru, you want to take this one also?
Sorry, how data loss prevention is operating? How can I ensure that my data is confidential if I have Envision Cloud while in the process of preventing the data loss? Does McAfee also have? Yeah, actually, this is a very good question. So McAfee obviously needs to have access to the data for us to be able to do data loss prevention, but does McAfee look into the data, persist it? It does not. So we have a model where we don't need to actually persist any of this data. It's all done in memory, and we are able to detect if it is apply those policies and check if it is confidential or not, etc., even without having to persist it. And also, we have a solution now, which we call as in VPC DLP, where we can do the DLP within the customer's VPC without the data even leaving your premises and coming into the cloud.
Right. So what that means is we peek into the data, and based on the policies, and policies define what is confidential or not, for example. So let's say you define a policy saying that if there is a credit card number in my file, then that is sensitive or confidential to me. And that depends differently for different customers. For example, if it's a finance or healthcare customer, they don't want credit card numbers to be shared in the documents, right, in the cloud. Then you can define a policy with a credit card number, and that's where we have this mechanism via APIs we can answer. The next one is, do we have a disaster recovery plan in the case of data center disaster? Where do you back up our data? So we don't provide DR, but within our solution, because we are also hosted in the cloud, our data is actually having a DR of our own. So we are hosted on AWS, and we leverage AWS capabilities so that we don't lose whatever data we show in our console with respect to incidents reporting, or let's say dashboards and so on. Okay, and the next one is funny. I think we don't need to take that.
That's a good question, but I don't have an answer to it.
Yeah, probably in the next webinar, we can take care of that as well in our presentation. Why Melody is so chocolatey.
Okay, I think there are no more questions, sir.
All right, thank you.
Any more questions from the participants? Any more questions from the participants? Satish sir, can you just try once if your voice is audible? No, sir, we are not able to hear you. Okay, there's some technical problem with Satish sir.
Sure, no problem, Shilpa ma'am. I will talk to him
Yes, sir.
offline.
Yes, sir. Thank you, sir. Thank you, Mr. Amit Agarwal and Mr. Guruprasad, sir, for taking your time from the busy schedule, and the lecture was really a very a meaningful one, and lot of concepts we got to know regarding the cloud security. Thank you so much, sir. I also thank Satish sir and our principal sir for helping us organizing this lecture series. We would like to again conduct few more webinars with you, sir, Amit sir, and Guruprasad sir, in the form of further more webinars. Thank you, one and all. Thank you, thank you, audience, for being part of this webinar. Thank you, sir.
Thank you. Thank you. Bye bye.
Thank you all.